This is how the white blood cells from your blood donations can be used to make granulocyte transfusion. This type of transfusion is only ever made to order. Hospitals ring us when they have a patient who needs one, and we have a matter of hours to get it ready. But first, what are the granulocytes? Well, they are the most common type of white blood cells, responsible for immediate response of your immune system. You'll have heard also that white blood cells are called leukocytes. In medicine, we give granulocyte transfusions to people with life-threatening conditions and cancers, helping them to fend off infections. So, in the lab, we begin by taking buffy coats. This is what's left in the middle of the blood donation bag after it's been spun in a centrifuge machine. These bags contain white blood cells and platelets, but some red blood cells and plasma remain. We need to keep just the white blood cells and platelets to make granulocyte transfusions. Because these components only make up a small amount of blood donation, we connect 5 buffy coats from blood groups of the same type and add 1 plasma unit and an additive solution called SSP+. A sterile docking device is used to connect the buffy coats to form a train. It's then hung up so everything flows to the bag at the bottom and form an intermediate pool. The extra plasma unit is helping to naturally suspend the components during this process. We then put this full bag in the centrifuge, where you will see gravity makes very distinct layers: plasma at the top, white blood cells and platelets concentrated in the middle, and red blood cells at the bottom. This then goes on a press to push out the remaining plasma and red blood cells into their own bags. They'll be used as part of plasma and blood transfusions, so nothing gets wasted. After 2 bags with just the white blood cells and platelets are obtained, we then go on a similar process. The bags are connected on a sterile docking device again, along with some plasma from one of the original donors. This then gets hung up with the content forming in the bottom bag. Only about 50 ml of the plasma is needed to put through the process. What's left looks like this, consisting of a single adult dose of granulocytes. Now comes some impressive science. These bags need to be going for the irradiation. In other words, a super strong X-ray machine. Because white blood cells contain DNA, we need irradiation to effectively deactivate DNA, to stop the risk of these cells multiplying and taking over the immune system of the wicked patient. So we know which bags have gone through irradiation and which haven't. We do know that by adding Ratio label to the pool. It will absorb radiation and change the color, going from red to black. As you can see, these bags coming out of the machine are irradiated. And all that's left to do is weigh, label, and validate transfusion bags.